Okay, on the previous page, I actually realized I was going to show you another method, and I'll show you on this page. So we were just talking about point-slope form. So I kind of messed this up. I put slope-intercept form. So point-slope form we were just talking about is y minus y1 equals m times x minus x1, where m is still the slope, and the line passes through the point x1, y1. And this is because we're going to use this form if we do not have the y-intercept. And I was just showing you how to do that form on the previous page, so I'll switch it up and I'll show you another way to find the equation of the line. So to find the equation that passes through the 2 points, whenever you're given 2 points, what do you think you would need to do first? Yeah, you're going to calculate the slope. So you have m equals, and I'll just write x1, y1, x2, y2, and my slope formula is the rise, y2 minus y1, that's the change in y, over x2 minus x1, which is the run, the change in x. Okay, so here, once I have the points, it makes it much more easy for me to plug it in. So I have negative 8 minus 6 over 2 minus negative 5. But whenever you have a minus a negative, what do you do immediately? Do you write plus 5? I would do that, make it a little bit easier for myself. Okay, now I have negative 14 over 7, which is equal to negative 2. On the previous page, I showed you how to use the point-slope form, so I'm going to show you another method. If I use slope y-intercept form, y equals mx plus b. If I have an equation where I only have one variable, I can solve for that variable. So this is just another method, not using point-slope form, using slope y-intercept. If I plug in one of my points for x and y, and my slope gets plugged in for m, I would have 6 equals negative 2 times negative 5 plus b, and then I could solve for b. If I solve for b, that's going to give me the y-intercept. So I have 6 equals 10 plus b. What could I do to solve for b? To get b by itself. In other words, what number plus 10 gives me 6? Well, to solve for b, I could subtract 10 from both sides. I get negative 4 equals b, and then I could use y equals mx plus b to plug in my slope. Here's m, and here's b, my y-intercept. So let's put it together. What's the equation going to be? Y equals negative 2x minus 4. So it just so happens that's the exact same problem. I believe that's the exact same problem we did on the previous page, but we did it with point-slope form. So I just reversed the order of things. Okay, hopefully I didn't make that too confusing. But if you look at your previous page's notes, isn't that the same exact equation? Can you confirm? Yeah, it's the exact same equation. I showed you already how to do it in point-slope form. So this is just another way of finding the exact same equation of the line using slope y-intercept form. It doesn't actually matter. If I were to do the same exact thing, as long as I use both of these points, here, I'll just do that really fast, okay? So, Yes, exactly. You have to be consistent. You have to use the same point. So if I were to take the second point, I could go y equals mx plus b. I don't know why I wrote it again. I could have just plugged the numbers in. But I'm going to use the second set of points. I'm still going to use the same exact slope. So I have y is negative 8, m is negative 2, x is 2, and I'm going to solve for b. So I have negative 8 equals negative 4 plus b. How do I solve for b? Add 4 to both sides, I get b is negative 4. It's the exact same b. Yep. Yes, y equals negative 2x minus 4 is the same exact, I get the same value for b essentially. Okay, so as long as you can do it either way, it's just that I was introducing the point slope form on the previous page, so I'm just showing you another method. Okay, so here this one says use the equation y equals mx plus b, write your equation of the line passing through this point using this slope. So we can do it either way. We can use the point slope form or we can solve for b. Why don't we do it? Actually, they're saying to use this method that I just showed here, and then they're saying use point slope form in the next one. So we're going to do it both ways. So if I know this is x and this is y, and I plug it in, I have y is negative 6 equals 1/9. What's x? 9 plus b. I want to solve for b. So I take 1/9 of 9. What is 1/9 of 9? 9 ninths, right? 9 ninths is the same thing. You could cross cancel here. You get negative 6 equals 1 plus b. How do you get b by itself? Subtract 1, good. And we get negative 7 equals b. So now let's put it into y equals mx plus b form. We know our b, we know our m. So we have y equals, here's slope, 1/9 x, here's our b, minus 7. So everybody see how I got that equation? Okay, now we're going to try the exact same thing. We're going to use the point slope form. So you see here, y minus y1 equals m times x minus x1. This is our point slope form. We have a point, x1, y1. We have the slope. This is m equals 1/9. If I plug it in, I have y minus negative 6, so I could write y plus 6 equals 1/9, that's our m, times x minus 9. That is the point slope equation, but remember we want to get it into this form. So I already have point slope. This is point slope form. But let's go ahead and solve for y. So what would I need to do to get y by itself to put it into slope-intercept form? First thing I would do, what do we call this? Distributive, right? Y plus 6 equals 1/9 x. 1/9 times 9 is minus 1, because 1/9 of 9 is 1. And then how do I get y by itself? Good. Subtract 6 from both sides. I get y equals 1/9 x. What's negative 1 minus 6? Negative 7. You see, I have the exact same equation. Doesn't matter how you do it. You do it either way, you get the same thing. Any questions on that? So that's two different methods to get the slope-intercept form.